Well, welcome again to one of my tutorial videos. Today's video is going to be about creating half equations, and it's in my series of videos on redox chemistry for A-level. If you've not yet seen any of the other videos, I would suggest that you have a look at the oxidation number video at least before watching this one, unless you're very confident with oxidation numbers, also known as oxidation state, in which case, welcome, and I hope you get something out of this. Now, half equations. Half equations do not exist on their own. They always come as a pair. So there will always be two half equations, one showing the oxidation side of a process and one showing the reduction side of a process. But often it's useful to have a look at a half equation to look at one part of the process in isolation. And let's look at a real example here. In the soil, bacteria convert the nitrate in the soil into nitrogen gas. Now the nitrates in the soil can be found as the NO3- ion, the nitrate 5 ion. And obviously nitrogen gas is the molecule N2. So we have here a redox process going on. We've got the nitrate ions, NO3- being converted into nitrogen gas, N2, in the soil. Well, therefore, we should be able to write a half equation for this process. And to do that, we need to follow some rules. There's a 4-step process that we need to run through. And this process, each step, taken in turn, works for creating any half equation. So if you know these steps, and you know the key reactant, and you know the key product, then you can follow these steps through to create any half equation you want. So let's have a look at it in detail. So first of all, I would suggest you, on a piece of paper, you write down, with plenty of space, the NO3- ion on the reactant side, leave loads of room, an arrow in the middle of your page, and then the N2 molecule nitrogen gas on the product side. And again, leave plenty of space. So these are our two key things that we know about. Nitrate ion NO5, NO3- nitrate 5 ion, NO3-, and the nitrogen molecule N2. So, 4-step process. Step 1 is to balance anything in our half equation that isn't oxygen and that isn't hydrogen. So in this case, in this particular example, we're talking about balancing the nitrogen. We need to balance the nitrogen first. Now, taking a look at your equation, you will see straight away that we've got 1 nitrogen on the reactant side, 2 on the product side. So step 1 is to balance the nitrogens up, 2 on both sides. That means placing a balancing 2 in front of the nitrate 5 ion. So it should read, on your piece of paper now, it should read 2 NO3- on the reactant side, and it should say N2 on the product side. Step 1 complete. Step 2, balance oxygen. Now you won't need to do all of these steps every time with the half equation. Sometimes the hydrogen and oxygens aren't present, don't need to balance them. Sometimes your half equation will be already balanced for things that aren't nitrogen and hydrogen, in which case you can leave out step 1. But take each step at a time, think about it, see whether you need it. If you need it, use it. So here in this case, we do need to balance the oxygens. We've got 6 oxygens on our reactant side, we have none on our product side, and to balance oxygen, you add water. So in this case, we've got to add 6 molecules of water onto our product side. So our equation should read now 2 lots of NO3- on the reactant side, and then on the product side we should have N2 plus 6 H2O. So our nitrogens are now balanced and our oxygens balanced. Now we're on to step 3. Now clearly the hydrogen is not yet balanced, so we have to balance the hydrogens. And to balance hydrogen in a half equation, all you're allowed to add are H plus ions. Now here, in this particular case, we have got no hydrogen on the reactant side, and because of our 6 water molecules, we have 12 hydrogens on our product side. So that means we need to add in 12 lots of H plus on the reactant side to balance up both sides of our equation for hydrogen. So on your piece of paper, you should now have written 2 lots of NO3 minus plus 12H plus makes N2 plus 6H2O. Now we've got each of the key species present in our half equation now. As you know, half equations also have electrons. So the final step of our process is to add in those electrons. Now this can be a little bit tricky. Now the first thing you need to do is to put the oxidation numbers into this equation as it stands at the moment. So the oxidation numbers that are relevant here, the nitrate 5 ion, the nitrogen has an oxidation state of +5. The oxygens in that ion are -2. The hydrogens in the H plus ion are +1. The nitrogens in the molecule of nitrogen are 0 because it's an element. The hydrogens in the water molecules are +1, and the oxygens in the water are -2. So looking at that, you will see that it is a redox half equation because the oxidation number of the nitrogen is changing from +5 to 0. And we have, in order to do that, to go from +5 to 0, if you remember what oxidation number or oxidation state means, let me remind you of the definition. Oxidation number means number of electrons lost or partially gained as a result of bonding. So in the nitrate 5 ion, the nitrogens have an oxidation number of +5, which means that they have partially lost 5 electrons, +5. In nitrogen, the molecule, on the product side of our equation, the nitrogens have an oxidation number of 0, which means they haven't lost or gained any electrons as a result of bonding. So each nitrogen has gone from +5 to 0. Each nitrogen, therefore, must gain 5 electrons. There are 2 nitrogens on each side, so that means a gain of 10 electrons. So to complete our half equation, we now have to put in +10 electrons onto the reactant side of our equation. So now the reactant side of the equation should read 2 lots of NO3 minus plus 12 lots of H plus plus 10 lots of electrons, which are written as E minus, makes N2 plus 6H2O. Now, to check that our half equation is correct, we should just check that the overall charge on the left side is equal to the overall charge on the right side. Now, the overall charge on the right-hand side is 0. Nitrogen has no charge, water has no charge. There is no charge on the product side. So the overall sum of the charges on the reactant side should also come to 0. So let's have a look at that. First of all, 2 lots of the NO3 minus ion, that's 2 minuses. We've got 12 pluses on the H plus, so that's 2 minuses, 12 pluses, and then we've got 10 more minuses on the electrons, and if you sum all of those negatives and positives, it comes to 0. Our charge is balanced. We have a complete and correct half equation. Now, if you follow these 4-step rules, you should be able to create any half equation. It would work for 2 very important oxidation half equations that you will come across in A-level chemistry. For example, you'd be able to write, using these rules, the half equation for the manganate 7 ion, MnO4 minus, making Mn2 plus. You'd also be able to write a half equation for the dichromate ion, Cr2O72 minus, changing into the chromium ion, Cr3 plus. Now, have a go. Give it a try. If you want to pause this video and see what you get, and then if you press play in a moment, I will tell you the answer. But give it a try first and see how you get on. Follow those rules and see how you get on. So if you're ready, here are the answers. So for the first one, you should have ended up with MnO4 minus plus 8H plus 5E minus makes Mn2 plus 4H2O. And for the chromium example, you should have ended up with Cr2O72 minus plus 14H plus 6E minus making 2 lots of Cr3 plus 7H2O. I hope you did well with that, and I hope you found that useful, and see you again next time for more chemistry videos.